Alrighty, hello. So what we're going to be talking about today is evaluating expressions. All right, so what we're going to hopefully be able to do is do that when there's variables involved and when we're using our order of operations. So we've got some basic terminology to get out of the way first. So a variable is just a letter or a symbol we use to represent some sort of number that we either don't know or a number that might change. Right, so common ones are x, y, you might see a, b, and c, right? A coefficient is the number that's in front of a variable, and it kind of like has hidden multiplication going along with it, right? So you might see 3x. The 3 is that coefficient, but what's really going on there is that it's like saying 3 times x, right? Mathematicians like to make a lot of little, shortcuts for things, so that it really is 3 times x. When we're talking about terms, they're the chunks of an expression. They can be numbers, variables, or a combination of both. Right, so if I had like 3x plus 7y minus 4, then what we would say is that the terms are 3x, 7y, and negative 4. Right? They're all the different pieces that are kind of separated by these things called operators, which, next up, operators are what we do to the numbers and variables, right? Your common ones are addition, subtraction, multiplication, and division, right? So again, terms are separated by operators. For operators, you might notice that there's a little dot for multiplication, right? You could also use this little star thing called an asterisk, right? Please do not use x to represent multiplication, right? That's not what we want to do because x is a variable, right? You don't want to be confusing one for the other. As far as division goes, right, you could also see something like just a little slash like that. Or sometimes you might even see an actual fraction, right? Fractions are just division. An expression itself is a collection of terms separated by operators, right? So this piece that I wrote up here, this 3x plus 7y minus 4, that is an expression at the end of the day. And then what we're going to be doing today, evaluating, is what we call it when we plug in values for variables that we know about, and then we're going to simplify them using our order of operations, right? And that's really all these steps are, right? Substitute the numbers in for the correct variables, and then simplify using order of operations, or PEMDAS, right? So just in case you forgot, P stands for parentheses, right? Take care of anything in the parentheses first. E is for exponents. So if I add 2 to the third, what we're worried about right there is that 3, that's the exponent. M is for multiplication, D is for division, A is for addition, and S is for subtraction, right? Something you may have run into in the past is that multiplication and division are grouped up together, and then addition and subtraction are also grouped up together, right? So you can do multiplication and division as one step as long as you go from left to right, right? Whichever one you run into first, right? If you run into some division, that's fine, and then you do some multiplication later on, that's fine. Same thing for addition and subtraction, right? Start from the left and go to the right, doing whatever sort of addition or subtraction is in your way, right? Let's take a look at some actual problems. What we've got here is 3x minus 4 when x is equal to 5, right? So x is equal to 5, that's what we're going to plug in. So instead of writing 3x, I'm going to write 3 and plug that 5 in. But that looks a little weird, doesn't it? Right? So that 3 is a coefficient. Remember I was saying that there's like a little bit of invisible multiplication between those? When we're plugging in that x equals 5, we got to be pretty careful, right? We don't want to write it down as 35. That's not correct. What's really going on there is 3 times 5. Right? So what I might suggest is when you're plugging numbers in for your variables, if you have something that's directly next to it, like this 3 is directly next to the x, put the x thing in parentheses like I did there, right? That way you'll be sure not to make any mistakes where it's like, oh yeah, 35 minus 4. Right? After that, it's just order of operations, right? So I do have parentheses, but I can't do anything inside them, right? It's just 5. I don't have any exponents. I do have some multiplication I can do, right? 3 times 5, that's going to give me 15. And I bring down that minus 4. And then addition and subtraction, 15 minus 4 is going to give me my final answer, which is just 11, right? Nothing super fancy, just taking it one step at a time. All right, but again, when you're plugging in that x equals 5, I really recommend putting parentheses if it's directly next to something else. All right. Let's try this one out. We got x squared minus 7 when x is equal to 8. All right, so again, x equals 8 means that we're going to replace this x with an 8. All right, so when I'm plugging that in, I'm going to put it in parentheses because I got that squared right next to it. And then minus 7 comes a little bit later. So again, order of operations. I've got those parentheses that I can't do anything about, right, because it's just 8, so those are done. I do have an exponent of 2, so I got to take care of that. So don't forget, squared means that you're multiplying that number by itself, right? So in this case, 8 times 8, 8 squared, is going to give me 64, right? I'm going to bring along that minus 7. And then there's just that one last bit of subtraction to do, right? 64 minus 7 is going to bring me down to 57 for my final answer there. Hopefully it doesn't seem so bad, right? Plug in the numbers, go ahead and do the order of operations, and then you're good to go. Sometimes they start looking a little bit worse, something like this, right? We know that x is equal to 3, so when we have 2 to the x power minus 1, and then in parentheses 1 minus x, we're going to replace both of those x's with 3's. Right, so in this case, that's going to look something like this. We're going to have 2 to the third power minus, and then in parentheses, 1 minus 3. So you might notice that I didn't put parentheses around that second 3 that I wrote, right? That second one in red. That's because there isn't really anything that's directly next to it, right? There's a minus sign and there's some parentheses, but those aren't really going to get in the way of writing it down correctly, right? So in this case, I'm fine to leave the parentheses off. If you're feeling a little iffy about like when to have parentheses and when not, it's something that comes with time and practice, like getting to know like, oh, this affects this, right? You will get better at it over time. If you want to put parentheses around it, you can. It's not going to hurt anything, right? So thinking through this problem, order of operations, I've got these parentheses here that I want to take care of first. So I'm going to bring down 2 to the third power. And then from those parentheses, 1 minus 3 is negative 2. Right? So again, be real careful with stuff like this because you might notice now that I have 2 negatives. I have minus negative 2. Right? If we're kind of tidying this up, I can turn that into one big old plus sign. Right? Because again, 2 negatives will cancel each other out. If you say, I'm subtracting a negative, it's the same thing as adding. After that, for order of operations, I've got this exponent here, right? 2 to the third power, right? So again, that's 2 times another 2. Altogether, that's going to give me 8. So overall, all I've got to do is 8 plus 2, which is just going to give us 10. Hopefully seems easy peasy. All right. So if you haven't tried one yet, try pausing here. Try this one out on your own and then unpause when you think you got it. All right, so hopefully you did that. Right? On this problem, what we've got is that x is equal to 3. Right? So all I'm going to do is I'm going to plug 3's in where they're supposed to go, right? Wherever those x's were. All right, so you might notice that I'm not putting parentheses around that 3. That's because it's not going to get in the way of like confusing us with anything else. This second one, I am going to put parentheses around because we don't want to mistake that for 23. Right? We want to remember that that's 2 times 3 going on there. So I'm thinking about order of operations, right? I've got some parentheses, but it's just a 3. I can't do anything in those. So I'm going to move on. I don't have any exponents, but I do have multiplication and division, right? So again, I'm going to go from left to right on this problem, and I'm going to figure out what those are. So first up is that division there, right? Remember that fractions are just division. I'm going to have 3 minus, and then 9 divided by 3 is 3, right? And I'm going to bring everything else down exactly the same as it was. After I take care of that division, I now have this multiplication that's at the end of the problem. All right, so again, bringing everything else down as it is, 2 times 3 is going to give me 6. All right? So I kind of ran out of room, so all I'm going to do is I'm just going to scooch this up there. Right? Same problem. 3 minus 3 minus 6. All right, so again, thinking through order of operations, now we're on to addition and subtraction. So left to right, 3 minus 3 is going to give me 0. Bring down that minus 6. Last but not least, 0 minus 6 is negative 6. And that's all we got to get through. right? Just get to -6, and then we're done. Oh boy, this one looks like a lot of fun. All right, so again, one step at a time. This one, we know that x is equal to 9, and we know that y is equal to -6. All right, so anywhere you have an x, make sure that you plug in the value for x. Anywhere that you have a y, plug in the value for y. That's really all that's going on. So in this one, that's going to look something like this. We're going to have 8 times that 9 plus 6, some parentheses with a -4, and then a -6 that's multiplying with it, and then plus 5. All right, so this looks like a bit of a mess. We're going to take it one thing at a time, just like always. So what we're going to have here is I'm going to start in these parentheses. Right? I got to start in the parentheses. When I'm inside the parentheses, I then have to still worry about which thing I do first. So when you hop into the parentheses, imagine that your PEMDAS starts all over again. I then got to think, all right, I have more parentheses with that -6. I can't do anything with those. I don't have any exponents, but I do have some multiplication to do here, right? So I am going to take care of that inside the parentheses first. Right? When we've got -4 times -6, that's going to come out to be +24. Right? Now that looks a little bit better already. Right? Next step, we're still working in those same parentheses. Now we've got 24 plus 5. So again, bring everything else down just as it was. 24 plus 5 is 29. Right? Again, I'm out of room a little bit. I'm just going to scooch this up over to the side. Right? I'm going to copy it down the exact same way. One of the biggest times that I find people make mistakes is when they are copying a problem down to another spot and they're trying to do a step at the same time. Right? So just take another second, write it down again, and then we'll keep on going. So from here, I've got multiplication to take care of. 8 times 9 is going to give us 72. Right? And bring everything else down. After that, we've got the other bit of multiplication, 6 times 29, which is going to be lots of fun. All right, let's see what 6 times 29 is. 174. All right, and last but not least, we add those together. That's going to give us 246 overall. All right, so some of these numbers can get a little bit big depending on what you're plugging in and all that. All right, but that's okay. Take it one step at a time. You just saw me use a calculator. Use one if you need it, and then it'll be all set. All right. So again, pause here. Try this one out on your own. See if you can get it. Hopefully you did that. I'm going to run through it real quick. I got an x that's equal to 5 and a y that's equal to -4. I'm going to replace the x with that 5. And then I'm going to replace that y with -4. Okay. First things first. Again, I have some parentheses, but I can't do anything in them, right? Because it's just a -4. Let's kind of zoom in there. I do have some division right here at the front. So 15 divided by 5 is going to give me 3. So that's going to come out to be a negative with that 3. And then everything else stays the same. Right? If you're getting to a point where you're like, well, why don't we just multiply at the same time with the 9 and the -4, right? You're perfectly fine to do that. If you're starting to feel more comfortable with these, definitely you can do that, right? As you get better at math, you can take more shortcuts and it gets a little bit easier, right? But it takes practice. And I'm going to take care of that division now, or multiplication now, rather. Right? 9 times -4 is going to give me negative, 36. Right? Just like one of the earlier problems, you might notice that now we can turn that into one big old plus sign because it was a double negative. And then -3 plus 36 is going to give me 33 as my final answer. All right. So, again, what I might have you do is try 7 and 8 on your own, right? Pause here and then unpause when you think you got them and then check it against what I did. I'm going to run through them real quick. So, x equals 3, y equals 8. Start off by replacing everything. All right? I got -8 times that 3 there for the x. And then 5 times that 8 for the y. All right? So first things first, I'm working in these parentheses. All right? Again, once you start getting a little better at these, you can take shortcuts, right? What I'm going to do is I'm going to do -8 times 3, which is -24. Right? We can kind of write that in there if it helps. And then I'm going to subtract 7 more from that, which is going to bring me down to -31. Right? So I still did the same steps. I just didn't write out the whole thing with each step, right? If you still want to write out each step just to be extra sure, perfectly fine. All right, but for the interest of time and not having you guys have to sit here for 45 minutes, I'm going to kind of try and do some of those shortcuts here and there. All right. Then we've got some multiplication to take care of, right? 9 times -31. Oh boy. Let's take a look at that. That's -279. All right. We've got a plus sign. And then I'm also going to take care of this other multiplication, right? It's the same step. We're still multiplying. 5 times 8 is just going to give me 40. All right. When I add together -279 plus 40, it's going to bring me up to just a nice, reasonable -239. Right? Not too bad. Again, you just saw me use a calculator. If you feel like that would make your life a little bit easier, you don't have to do 9 times 31 in your head, right? It's always better to double check. Okay. And again, hopefully you paused and did number 8 on your own as well. Again, I'm going to run through it. X is equal to 8. Y is equal to 6. I'm going to start off by replacing things. It's 24 divided by 8. And this is now 3 times 6 for the Y. Right. So again, multiplication and division are all one step. I'm going to start off by doing that division. 24 divided by 8 is going to give me 3. The other piece here, 3 times 6, again, still in the same step because it's multiplication and division. 3 times 6 is 18. Okay. After that, what we can do is we're just going to start adding and subtracting. Right? 7 plus 3 is going to give us 10. And then 10 minus 18 is going to bring us down to -8 for our final answer there. All right. So again, hopefully this seems pretty okay, right? Plug in the numbers, do your order of operations. If you want to write out every step as its own line, that's perfectly fine. Nothing wrong with that. So let's talk a little bit about word problems. Hooray, everybody's favorite thing. So a local school is selling raffle tickets as a fundraiser to raise money for a field trip. The individual cost of participating in the raffle is given by this expression, 5t plus 3. So when you have an expression, right, and you're looking at what the variable represents, what we want to think about is, all right, what might be changing in this situation? All right, so there's a couple different things it could be, right? Is it the cost per ticket that's changing? Maybe the number of tickets they're buying? Is it maybe how much you need in order to even be participating in the raffle? Right? So in this case, T is going to represent the number of tickets. Right? So it's the number of tickets that you're going to buy. That's what T is. Right? That might mean that the 5 represents the cost per ticket. Right? So again, if I bought 1 ticket, that's 5 times 1. That's only going to cost me $5 for that ticket, right? Then we got to worry about what the 3 represents, right? And that one's a little bit harder, right? Sometimes when you're, imagine that this was happening at a carnival or something like that, you might have like a base cost to even like get into the carnival so that you could then buy the raffle tickets at the carnival. So the 3 is kind of like a base cost. It's kind of like a starting point. All right, so imagine that you needed to be able to get into this carnival where they're selling the raffle tickets, right? It's going to cost you $3 for admission, and then you can buy the tickets, right? So you need to pay that $3 even if you buy 0 tickets, right? You need to pay that $3 if you want to buy 100 tickets, okay? So then what we can do when we have expressions like these, and once we kind of piece together what those different chunks mean, is we can figure out problems like this. How much money will someone spend if they buy 10 tickets? Well, 10 is a number of tickets. That means it's going to go in for T. So T is equal to 10, right? Then it turns into one of the problems that we were doing a little bit ago. All I'm going to do is I'm going to plug 10 in where I had a t, and then simplify. All right, so 5 times 10 is 50. 50 plus 3 is $53 to buy 10 tickets. Right? I could figure that out if I wanted to buy 265 tickets. Right? I could plug in 265 for t and then solve it out the same way. Right? So this is what I was talking about at the beginning, where a variable might just be a number that changes. Right? T is something we don't know because we don't know how many tickets somebody's going to buy, but that number could change, which is why we use a variable to represent it. Right? Let's try another one out. Mr. Cobley, if you haven't met him, pretty nice guy. Mr. Cobley's math class is taking a field trip to the movies to see the new exciting math movie that's coming out. It's called Fraction Jackson, Episode 4, Revenge of the Denominator. The movie theater has a discount for groups depending on how many tickets and sodas they buy. So the cost for going is given by this expression, 3t plus 2s. All right, so on this one, again, we want to figure out what these different variables represent. So t, think about what t might represent here. Right? It's probably not the cost, right? Because the costs of things aren't changing. They're usually set. So it's the number of something that we're buying. Right? In this problem, they're talking about we have a discount for groups depending on how many tickets and sodas they buy. So t probably be the number of tickets, which means that the s in the next part, what the s represents is the number of sodas. Right? So think about it this way. Variables are talking about the number of something most often, right? It's like number of hours, number of tickets we're buying, stuff like that. As far as the 2 and the 3, right, those are the coefficients for those variables. So the 3 is in front of t. 3 is probably going to be the cost per ticket, right? It wouldn't make sense to put the cost of a soda right next to the number of tickets, right? It's saying that, all right, if I buy 3 tickets, that's 3 times those 3 for the price, and then that's going to be $9 total. If I buy 5 tickets, it's going to come out to $15 total for the tickets. Same kind of idea for the 2. The 2 is next to the S up top, so that's going to be the cost per soda, right? What a sweet deal. Can you imagine going to the movie theater and spending $3 on a ticket and $2 on a soda? Man, what a world that would be. So we want to figure out how much money will the class need to raise if they need 20 tickets and 7 sodas. So again, just like the problems we were looking at a little bit ago, 20 tickets, that means that my T is 20. 7 sodas means that my S is 7. All we got to do is plug those numbers in. So this is 3 times the tickets, which is 20. And then we're adding on the cost, $2 for each of 7 sodas. If I do that multiplication out, 3 times 20 is 60, 2 times 7 is 14, and all together, it's going to cost us $74 dues to bring everybody to the movies. It's pretty good for 20 tickets. Wowee. All right. We got one last little piece to talk about. This one's not really so bad. So we're going to create tables of values for these expressions. So this is not something that we're really going to need to do a lot, but it is helpful sometimes if you're having a tough time figuring things out, right? Especially when we get into graphing a little bit later this trimester. So we want to figure this out when x is equal to 1, 2, 3, 4, and 5. And the expression is 5x minus 5. So you can see we have all our different x values that we're going to plug in right over there, right? We've got our expression right there in the middle, and then this y is going to come out as our answer, right? So something we're possibly going to get into is talking about this as an input and this as an output, right? So we're inputting some number x, and then we're going to get out, when we simplify, some number y. So when we're doing this, right, and again, you don't need to do this way with the table all the time. Sometimes it's helpful for different expressions. But what I could do is I could plug in all these different values of x, right? So all I'm doing is the same process that we were doing on those other problems earlier, plugging in all these different x's into that expression, and then I would simplify them, right? So if I'm simplifying that first one right up here, 5 times 1 is, 5 times 1 is 5. and then I subtract that 5 for the second step, and my y is 0. Second one, 5 times 2 is 10. 10 minus 5 is 5. 5 times 3 is 15 for the next one. Minus 5 brings me down to 10. And then this can also help you find patterns like this one, right? It seems like it's just going up by 5 every time. Let's check out the next one to be sure. 5 times 4 is 20. 20 minus 5 is 15. 5 times 5 is 25. Minus 5 brings us to 20. All right, so we can kind of see a pattern developing with different ones of these. Right? Sometimes these can help us figure out the patterns for more complicated problems like this one. Right? This is called a quadratic function. This is actually something that you guys won't see until Algebra 2, which is a little bit down the road. Right? But again, same process. I can plug in all these different values of x and calculate what they're going to simplify down to, right, in this kind of easy way. So let's just take a look at this first one. Right? If I have negative 2 squared plus 2 times negative 2 plus 1, right? You got to be careful if you're using a calculator, right? Because what I'm going to tell you is that the calculator is kind of dumb. So let's put negative 2 to the second power, just like that. Comes out to be positive 4, right? Hopefully it makes sense. If I multiply negative 2 times negative 2, I get a positive 4. Be real careful, again, if you're using a calculator and you don't put the parentheses around it, oh dear. Calculator isn't as smart as we are. It's faster, for sure, right? But it's not as smart as we are. So make sure that if you're supposed to have parentheses, put the parentheses, because the calculator won't know the difference. So what this is going to come out to be is this is going to be 4 plus 2 times negative 2 is negative 4, and then plus 1, right? So when I go through and I do all that, right, we're going to have 4 minus 4 is 0, and then plus 1 brings us back up to 1, right? I know that I'm running a little bit long. If you want to keep finishing up this table, it is going to be finished in the notes that I'm going to upload to our Google Classroom, so if you want to check there, definitely do. If not, then I think we're all good on this one. As a reminder, you don't need to do the practice problems that are at the end of these notes. We are going to take care of those in class so that I can help you out if you have questions. So have a good rest of the day. See you next time.